See here, what is computer science? We continue our discussion on this definition, and we have found that computer science is a science of abstraction in which two things will be done. One is problem representation, and the other one is development of algorithms. Now, to tackle this simple solution, what's meant by simple issue? Simple issue is developing solutions that are correct and efficient. Now, what a computer scientist like us have to do? Now, various algorithms are to be combined, and whether a solution can be obtained for a problem or not, this should be determined. See, algorithm is just a blueprint. Once we design the algorithm, we don't know on which machine the code will be written and using which machine it will be implemented. Before implementing itself, the blueprint is subjected to a series of tests to classify the task. So if an algorithm cannot end within a finite amount of time, there is no value for that. What will happen? When you implement this algorithm, machine will not respond after certain time, say. What you will do? We'll use our ultimate tool for powering off or rebooting the system. That's it. So it should not happen. So this is a hard task for the computer scientists to determine if an algorithm provide a correct and efficient solution for a definite problem. Now, further, they have to see once an algorithm is implemented, it will remain dormant in the paper. The sketch will be there. See, our building plan is made, plan is beautiful, but if it is not materialized, no one can live in that building. No one can use that. Similarly, if the algorithm cannot be turned to a computer program, it is of again no worth. In that case, we need programming languages. So once a programming language is designed, then we can use that programming language, say, for the implementation of our design. And design of programming languages is also job of computer scientists. Then what? Then computer scientists, they have to design, evaluate, and build computer systems which can run their programs. So each program may require a bunch of resources, and computably efficient machines have to be developed to run our softwares. So even this task is being done by computer scientists. This is now the various aspects of the science we are exploring. Now you can look at the various courses you have done for your BSc degree and the courses you have to do in your MSc degree. You will get enough justifications of why a particular course is included in a bachelor's or master's program in computer science. Even if we are not interested in a topic, that we can see that that course is given as a core course by the syllabus, by the people who created or designed the syllabus, because a knowledge about those areas will be fundamental to computer science. That's why they have included. Now let us look back to the history, how this field was evolved. And see, it is, if you look at the history, it's open in our hand, on our fingertip. When we look at history will be having a lot of perspectives, and we should see in the problem solving aspect of the computer history, how the problem solving aspect was there right from the ancient men when they thought about computation. That's our search now. See, foundations of computer science were laid by our ancestors even long before the invention of modern computers. I leave this sentence as such now. This sentence is self-explanatory, and you can come back to this sentence once this session is over, hopefully, today or tomorrow. See, our ancestors, they were using fingers initially. The Almighty have given us 10 fingers. So the ability to count using these fingers were efficiently used by our ancestors before to count their number of wives, number of children, number of trees they can hide, number of animals they have hunted, number of caves they have built. For all these things, they need some objects. Obviously, they use fingers. Later, they found that fingers were not enough to accommodate their needs. Then they used pebbles. Pebbles were used for calculation. And years went on like that. Later, the volume and type of need were exploding. They realized that mere pebbles or fingers were not enough to do their calculations. So here we can see that our ancestors had a real problem in their life. They started solving that. See, that is inherent to us. Solving problems, arriving at a problem and finding the efficient solution for it. It is not limited to computer science. It was part of our gene. That's what we see in this history. Then our ancient people, they developed a tool called as abacus. This abacus is still in use to teach small kids how to count and compute. And this machine was used as early as in 2004 before Christ. And they did their additions and subtractions using this abacus. But of course, you can add and subtract using a tool, but how did they know that there is a method for that? When you add 9 and 1, you have one digit extra, 10. How this one digit will be placed? When you add 19 and 2, and when you go to say 19 and when you add 3, you have one more digit coming up. So how these positional notations and all these rules, how could they knew about these rules? Of course, they had tools, but how did they knew how to do this process? See, it is very important. You have a problem, you design the solutions. Between the problem and the solution, there has to be a process. If that process is clearly articulated, there is a solution as per that process. See, the rules, or now we can say it as the algorithms. And what is a rule? A rule or algorithm is a clear-cut description of the steps for some operations. See, these rules were in force even centuries back. There are many instances to quote. And you can see in history a book called as The Rules of the Code, or Shulba Sutras, which was written in 800 before the Christ. And this book was written in India by Indian scholars. There, the geometric objects, how the geometric shapes could be formed, these were clearly articulated. And this is still considered as an authentic book for building geometry objects. Similarly, we can also see a person called as Muhammad al-Khwarizmi. And this person was a Persian scholar. And he was the person who wrote the rules for adding, subtracting, and multiplying and division. So how these steps we do now? We have a carry forward system. We have a positional notation. So all these were not developed in a single day. Muhammad Al-Khwarizmi was the brain behind this algorithm. And the word algorithm itself, it is derived from Al-Khwarizmi's name because Westerners were not good in pronouncing Al-Khwarizmi, so they made algorithm to name Al-Khwarizmi. And algorithm was termed as the term as such was derived from his name. And even his name was, even his works was based on 7th century Indian mathematician Brahmagupta. So here you see that for acquiring knowledge, there is no religious or territories bars. Our ancestors, they vehemently traveled each locations where knowledge is there. They learned the language and they understood the basic books. Then they created their own works based on the fundamental concepts. So real research they had done when there was no Google or no proper means of transportation and communication. Now, coming back to this, the fundamental problem of computing, calculating, see fingers, pebbles, abacus. Then the attempt was to produce automatic calculators. And see, we will list only few noted milestones in these slides. There are several inventions and several visionaries that we will miss during this slide because an entire semester will not be enough to present all of them. Several automatic calculators were reported. The most notable was in 1642 when Blaise Pascal put forth his first working mechanical calculator. And in around the same period, see in 1673, Gottfried demonstrated a digital mechanical calculator. And he named this as Stepped Reckoner. And this contribution, he was also documented, he was responsible for documenting binary number system. And we know that binary number system is fundamental to computer science, and without that, we don't have a computer system at all. People don't have even an electronic device during those times, but the documentations done on 16th century, see, it is the base of this mighty system called as computer science. Now in 1820, there was another invention. It was made by Thomas D. Colmar. He launched a machine called as simplified arithmometer. And this machine was a portable machine which was reliable enough to be carried to an office environment. So in this year, we got a device which could be used for computing our calculations. A calculator as such, mechanical calculator. Then comes the real step. See, in 1822, Charles Babbage, a UK-based scientist, he worked on the design of the first automatic mechanical calculator, how to automate the process of calculation. And he designed a machine called as difference engine in 1822. So far, we have seen that humans were successful in implementing machines to do calculations. But how to make them programmable? That was the dream then. We have machines which can calculate whatever we instruct. If you say add 2 and 3, it will add. How to program a machine so that several kinds of calculations can be done on the computer. Once you give a program, that will be done. So this dream came after that. See, again our Charles Babbage, he had a dream about a programmable device. Then he started his work on a machine called as analytical engine in 1834. Not the year, in the 18th century. Within 2 years, he could complete the sketch of his design. So Babbage's sketch was ready during that time. And see, this is very interesting how Babbage could make the sketch of the machine and how the programmable aspect was built into Babbage's design. See, here, there around the same time in 18th century, during Babbage's time, there was another invention called as Jacquard loom. See, this Jacquard loom is see, we will see what is a Jacquard loom. See, prior to 18th century, there were even textile design on those days. Beautiful textile design was done with the help of few experts, and they were doing with their handmade design. Companies had to spend a lot for that, and there were only few limited experts in that area. This resulted in huge cost for the production and even time delay, because an expert has to finish a design by his hand, then only he can start another design. This in 1804, Joseph Marie Jacquard, he developed a machine called as Jacquard loom. This Jacquard loom has a nice concept of punched cards. What will happen? In a punched card, you can etch a design. Then this punched card can be fed to this loom. What is a design in the punched card? It will be printed on the textile. See, a programmable loom. There is no need of a human expert. All that you have to do is you create different designs on the punched card, and you can use the same device for creating several designs. See, a programmable dress designing system. Now, Babbage noted about this punched card, and he thought about making use of punched cards for his as an input device for his dream machine. And that's why we have written this here. Charles Babbage had sketched out many of the salient features of the modern computer system design. And he even used Jacquard loom's punched cards system as a part of his design. So we can say that it is a pure interdisciplinary research. What do you mean by interdisciplinary research? See, if your major area, say, is in mathematics, you can combine with few of the people, say, in statistics, to develop a combined theory, a combined process, a combined thesis. So this is happening nowadays now.